What is up everyone, welcome back to my channel. In this video we are going to explore what is PCG in Unreal 5.5. So PCG is known as the Procedural Content Generation. It is a system in Unreal Engine that automates the creation of the game content using rules and logic. It was first introduced in Unreal 5.2 and now it allows the developers to generate assets dynamically like forest, cities, terrain and other features. It uses a graph-based workflow for customization and good control. It is basically used to save time. It ensures scalability for large projects. So without further ado, let's get started. Alright, let's start with enabling the PCG framework plugins in this Unreal 5.5. So over here I have created an empty Unreal project and let's start with enabling the plugins first. So go to edit and plugins, search for PCG and you will find these plugins over here. You will find that these plugins are experimental because these are introduced in 5.5. So let us just enable all of them and then we will have a look into the features of PCG. So we'll mainly focus on the procedural content generation framework, which is currently in beta stage. So I'm just gonna take all of these. So PCG works with Niagara as well now. It's in experimental. Alright, let's restart the project. So the plugins are now enabled. Project has been restarted. Let us save this empty level first. So I just hit Ctrl S. Just gonna right click and create a new folder in the content folder. Call this as levels. And I'm just gonna rename this as PCG test level. Let us create a new folder for PCG graphs. So right click and I'll create a new folder PCG, and over here inside you will find the asset of PCG right over here. So we have PCG graph, PCG graph instance and PCG builder settings. Firstly, we'll just explore what is in the PCG graph itself. So click on it and let us just rename this as PCG sample. Okay. I'll just open this up and you'll find a new window for PCG itself. Let us take a quick look at the interface for the PCG graph. In the center, you will find the graph itself with two default nodes, which is an input node and an output node. On the left hand side, you will find different nodes which can be used in the graph, and you will be using most of them to make the graph more functional. You will find that all of these nodes over here have been subdivided in different types. So blueprint node, we have control flow nodes, the debug nodes, density, filter, generic, and a lot more. On the right hand side, we have the settings or the details panel. So the PCG sample details has been listed right over here. If you just drag and drop any one of these nodes over here on the right hand side, you will find we have the details panel for that particular node. So that was it for the quick interface. And what we can do is just save this PCG sample and you can drag and drop this inside the level itself. And let us reset its location. You will find that it has a default scale of 25 by 25 by 10. In Unreal Engine, one Unreal unit is equals to 1 centimeter. So if you have 25 units, that means it is 25 centimeter of width, 25 centimeter of breadth, and 10 centimeter of height over here. Also, you will find that this is just looking like a volume, a default trigger volume, trigger box. And yes, it is. Because if you look at the details panel, you will find it has a brush component over here and we have a PCG component attached to this volume. If you look in the component, you will find in the instance we have our graph attached automatically. If you click on the sample and hit generate, you will find nothing is happening because we are not using any of the nodes in PCG yet. So let us start exploring with some of the basic nodes that you will be using for creating PCG. So the first node that we are going to explore is one of the sampler nodes. So if you just type sampler, you'll find we have different kinds of sampler nodes. We have copy points, we have mesh sampler, sample texture, select points, spline sampler, surface sampler, and volume sampler. We will be exploring surface sampler for the start. So just click on it and you'll find in the settings we have few settings for the sampler. By default, we'll not be using the input or output nodes. What we will be using over here is the landscape data node. So right click and search for get landscape data. So this will by default take the input for this bounding box as the landscape. So I am using the empty level over here, and if you are using any other level, make sure when you create a landscape you should be having the edit layers to be set to true. Okay, let's open this up. So this will automatically get the landscape data, and you find we have a surface node. So the surface to sample with points, it is defined as. So we have the landscape data. If you expand this, we have more data for the landscape to work with, but we'll just use the default data that we are getting from the landscape inside of this bounding box. So the bounding shape is just the box itself. We are not changing anything over here. So the subtype you find here is point, spline, landscape spline. So currently it's just a bounding box for us. So now let's hit save, and if I come over here and let me search the PCG sample, and you will also find when you drag and drop the PCG sample, the PCG world actor will be automatically created. Right, so if I hit generate now, well, you are using the component, but nothing is happening over here because we are not visualizing it, we are not debugging it. So for that you have to enable the debugging. So you will find the debug boolean over here. Set this to true, or from here right click, you can enable this, or you can press D as a shortcut. I just put this right over here so that we can visualize in the runtime. Alright, so you will automatically find we have few blocks or points which is being called over here. It is also defined as points over here, but I call it as blocks. Okay, so you find these are the points, and these are in shades of white and black, whereas white defines as 1 and black is 0. So these are the value of these points, or you can call it as the weight of the points, which is used for filtering and more. Okay, so let's take a look at the settings for the surface sampler. If you expand this, we have a lot more things that we can work with, but these are basically all the settings that you find it over here. If you want to change it during runtime, then you can use it to set it. If not, we can just set it over here. So let us take a look at what are the settings we have for the surface sampler. So firstly, let's have a look at the seed value. So the seed value is nothing but just a random value that we have over here. So for example, how is this being placed over here? It is just random. So if I just change value just by 1, so you will find this black node is over here, white node is over here. If I make this to 7, it is now really changed. If I set it back to 8 again, it is got back to its original value. So hence it is given this random number because you want it to be placed randomly anywhere. So I can set it to 0 itself, set it to 1. If you set it back to 0, it comes back to the same one. So yeah, just have the random seed over here. You can just slide between the values and you will find each time you have a different values. Alright, then we have for the points, we have point extends, we have points per square meter. So the point extends is just like the scale for it. Okay, so the points over here you'll find, if I suppose set it to 10 by 10, you will find it is much more scaled down. And over here we have points per square meter. How many points do you want in 1 square meter, in 1 meter basically? So if I increase this to 0.5, you will find that it is now more crowded. So you can increase it to like 1. So now it is more crowded. So this is how you can control it. And if you want to control it in runtime, you just have to use these values from here. You have to set it from here, right? Then yeah, you just have to know the maths for how many will it fit, because if I set this to 100, and if I increase the points per square meter to like 5, it is still the same, because it is not actually fitting inside this bounding box, right? So if I set this to 0.01, so now it is much more less, right? So these were the basic settings for the surface sampler. So I just set these to default. So now if I set this unbounded node to true, if you know about post processing, we have the unbounded node. So when you click on it, what happens is now there is no boundary for this surface sampler. The bounding shape is now, you see, it is now grayed out because it is unbounded now. It is covering the entire landscape by each part. So now you can decrease it to add more space between them. So like 0.01, if we do, you'll find it is less crowded. If you like make it 0.01, it is more or less crowded. So yeah, that is what this unbounded does over here. I'll set this back to bounded, and let's have a look at another node. So the next node that we are going to explore is the transform node. So transform, and just scroll down, we have transform points node. So click on this and hit save. So on the right hand side, we have the different transforms that we can apply to these points from the surface sampler. So we have the offset, the minimum and the maximum offset, the rotation min and max, the scale min and max, and you can set it either you want absolute rotation or you want the local rotation or the world rotation basically. And it has a seed as well, just to make it more randomized, right? So this also can be controlled from here. Okay, so now to visualize the transform points, so currently let us first try to add some scale over here. So let us start with let me first reduce this or increase this actually somewhat like this, make it a little more dense, and let us make it like 50, somewhat like this. All right, so if we go to transform points, and over here we have minimum scale, let us just play with the scale right now. So 0.5, 0.5, and this let us set to 2, but you will find there's nothing happening over here because of course the debug is set to false. So if we click on debug, you will find that now we have 2 debugs on. So at one time I would recommend to disable one debug and just use the debug for this. So now the debug for the surface sampler is now disabled, and now after the surface sampling is happening, then we are doing the transform points and we are debugging this one now, right? So now you can change this like 3 and we are debugging that. So this is just how you can actually add some offset over here. You can see the X offset, the Y offset, and the Z offset right over here. Now it is actually in the air. I just increased it a lot, right? So these are the offsets that you can set over here. We have the rotation, the minimum rotation, the maximum rotation that you can have in X-axis, the Y-axis, and in the Z-axis. So it is now totally randomized. So recompute seed you can add, or just change the seed from here, right? And then you can use uniform scale or absolute scale, absolute rotation you can set. So yeah, it is basically like from according to the local transform or the world transform, right? So yeah, these we can just reset now. So that was for the transform points node. The next node that we are going to explore is the filtering node. So from the transform point, I'm going to add a filtering node. So from the filter, we have lots of filtering nodes. We'll start with the density filter. Now remember, I told you about the gradings of the color grade. So start with black, which is 0, and white, which is 1. So that is the value or the density. So I will just right click and click on this debug, and I'll disable the debugging for this. So if I click on the density filter, you'll find that we have the settings of lower bound and the upper bound, and we can invert it. So the lower bound, meaning it is actually setting the lower threshold and the upper threshold. So here we are just cutting off anything below 0.5, and we are taking from 0.5 to 1.0. So these are the nodes which have the value from 0.5 to 1.0. If I just invert this, then it will just choose from 0 to 0.5 currently, right? So if I do 0 to 0.5, we'll get all those. So this is just a way to filter which kinds of value do you want from all of these nodes, right? I can disable this by hitting E, by enabling and disabling, right? So this is one of the shortcuts which you can use, and you can press D to enable the debugging, right? So as I said, we have a lot of nodes over here. From these, if I want to filter some points, so how you can do that? So you can use the density filter. So I just disable the debugging, enable this. So this is how you can filter this accordingly to your threshold. So for that, you can use density filter. One of the nodes that you can use is density filter. Now let us start with actually adding static meshes on top of these points. So how can we add that? For that, we have a separate node called this as static mesh spawner. So just search for static mesh spawner. It comes under the spawner. So we just search for spawner. We have different types of spawner: create target actor, point from player pawn, spawn actor, spline, and component mesh. So we're going to use static mesh spawner. Click on this. Let us attach this directly over here. I will disable the density filter by pressing E, and now we have a static mesh spawner right over here. So to actually get a static mesh, I found an amazing pack, which is the stylized forest pack, which you can find it on Fab. So I actually had this pack over here, and I quickly added it to my project, which is in 5.5. Right, let's get back. So yeah, this forest pack has the meshes, the static meshes that we can use. These are the trees, and we have some stones and some plants, right? So let us actually add it on top of these points. So we'll go to the PCG sample graph over here, open this up. So in the static mesh spawner on the right hand side, we have the debug, we have the mesh selector, which is what we are most interested in. So in the mesh entries, we're going to add one entry and click on this to expand, and click on this. You'll find the static mesh where we want to add. So let us add a static mesh over here. So either you can drag and drop, or we can get it through here. It is better to just drag and drop. So we get the stylized forest, meshes, trees. Let's start with some normal trees over here. So I'll get this tree 5. So drag and drop right here. Hit save. So now it is, I'll just disable the debugging for this as well. If we debug this, right, so as you can see, okay, let us not debug this, because if you debug this, then you will not be able to actually see the static mesh itself. So hit D again. So yeah, there you have the actual static meshes on those points, because our points that we had were really dense. So now what you can do is go to the sampler again, and from here you can decrease the points per square meter. So now it is set to 0.1. We can decrease to 0.01. Now it is somewhat like this. 0.05 is this, right? So, and you can also play with the density over here, the point extents or the scale actually. Okay, so also one thing that you can do is you can control the scale from here. So now some trees will be of scale 1, some trees are of scale 2 over here. So if I do like 0.5, some trees are of scale 0.5, as you can see one of them over here, and some trees are of scale 2. So that is the usefulness of this transform points over here. Now if we want to use the density filter over here, I just enable this and press E. So now we are only choosing the threshold between 0 and suppose 0 and 0.5. So we are using this threshold, or you can invert this, right? So this is the use case for the density filter. So here we have spawned the static mesh. So again, this is, if you go to landscape and you try to sculpt the landscape, let me just save this, and if you try to sculpt the landscape somewhat like this, and you will find that the trees are actually just directly connected to the landscape itself. So the points, actually the transform points over here, these are the one that you can control. Okay, so I'll just hit Control Z because I don't want this bump over here. It will recalculate. Yeah, okay, let's just keep it somewhat like this. So this is what you can do with the static mesh spawner. So again, you can add more mesh and trees, but it will be spawned at the same point, which is currently the tree is standing right now. So for example, if I increase the points per square meter, so currently it is 0.15. If I set this to 0.5, well, it is a lot more. If I set this to 0.3, and you will find that in most cases that the trees are overlapping with each other over here. They are intersecting a lot. So to avoid this, what we can do is we have few nodes called as self pruning. And so before that, what we can do is after density filter, we can add a node of bounds. So search for bounds. We have bounds modifier. If I'll attach this bounds modifier and try to debug this, press D, and if I disable this for now, so this is the bounds modifier over here, and if I click on this, you'll find it has minimum bounds and the maximum bounds. So this bounds should actually represent the actually width of the static mesh. If I enable this again, well, you'll find that the static mesh currently is a lot more bigger than the bounds itself. So what I will do is increase the maximum bounds to set to 2, and this also 2. Still it is little bit less. Let's set this to 3, and this one I'll set to 2. Alright, so now you'll find we are actually almost overlapping with the static mesh. So now we know that the bounds is actually little bit better. So from this bounds, what we can do is, for example, this is almost getting overlapped. So from this bound, we can add pruning. So self pruning, and I'll attach this over here. So now what happened is the ones which are overlapping are now separated. So now you will not find any one of the trees which are actually overlapping with each other. So that is what this self pruning does, and the bounds make sure the exact width of the trees over here. So with the help of the bounds, then we can calculate the self pruning. So let us debug this now, and I'll disable this. So after pruning, this happens, and if I disable this, this is before pruning. We have lots of overlapping over here, and if I enable this, press E, so now they are not overlapping with each other. So this is what the self pruning does. So I'll disable the debugging, and now I can just play with this over here. I'll set this to 0.2, 0.15 or something, and yeah, now they are placed much better. So now you want to add more static meshes. So currently we have only one static mesh spawner over here. If I add another static mesh inside this mesh selector, it will be spawned right at the same place on the same point. So to actually add another static mesh, what you can do is you can add one more route from here. So you can add another surface sampler. So surface sampler within the same landscape data, within the same bounding box. So from here we can add transform points, and from here you can add the static mesh sampler, the spawner actually. So yeah, from here now you can add mesh entries, a new one, and let us add a rock. So let's choose this one. Okay, I just drag and drop the static mesh, and I'll hit save. Alright, and let us debug what is happening. So these are the transform points. I'll press D, and these are the pruned points. I'll press D over here as well. I'll hit save, and let's take a look at the environment. So now over here you will find that the stone and the trees are overlapping, and the stones are overlapping with itself. So now you know what to do when the stones are overlapping itself. You will do pruning. So if I want, I can do the density filtering, but yeah, it's just up to you. So I just duplicate these, but the bounce modifier for this I don't need. I don't think we will be needing that because it is almost fine. So I just use density filtering, and then I will use the self pruning as well, and then I'll attach the static mesh spawner. So now you'll find that there are no stones overlapping with each other. Alright, let us now actually scale down. So from here, let us reduce this to 0.05. Seems fine, and let us scale down. So the min scale, let's set to like 0.5, and the max scale, or maybe less, 0.3, and this let's set to 0.5, or let's set this to 1. All right, so now you will find in some places we have both of them overlap. So what to do? We cannot. So self pruning is different, right? Press D over here. So yeah, as I'm saying before, the self pruning is for the each static mesh. How can you differentiate between both of them? So we have a difference node. I will right click here in the graph and search for difference node. So what this different node will do is actually do the basic A minus B. So what I'm going to do is, firstly, I'll set the density function in the difference node. I'll set this to binary, and this self pruning, which is of the tree, we are going to subtract. So this is the source. Subtract this from the self pruning node of the stones, and then I'm going to just display the trees which are separate from the stones. Right, so these are the placement of the trees which are separate from the actual stones. that is what we are doing over here. So this is what the difference node does. So now you will not find any of the stones overlapping the trees, and also we are using the self pruning, so no trees are overlapping with each other and no stones are overlapping with each other. So this is what the difference node does. Now for example, you have a static mesh in your scene itself, so I'll just get a simple cube right over here, and let me just scale this to 5. And you don't want any of your meshes of the PCG to overlap this cube. So how is that possible? So for that we have a node. We will just get the actor data from here. So the actor data, so the actor filter will not be self, it will be all world actors, right? And which actor to select will be determined by the actually component, the tag actually. So the actor selection tag, so actor selection will be by tag, or you can do it by a class. You can get the actor by class, or you can do that, but we have the actor right over here, we can get it by tag. So let's give a tag to this actor, so PCG underscore actor. I'll copy this, right, and let me just hit save. And this cube I'm going to search for tag, and inside the actor tags I'm going to add a tag over here. Now what I'm going to do is I'm going to do the differentiate. So this will go to the differences, so there can be multiple differences over here. That means, so now wherever my cube is, there the tree will not be spawned. Same you can do for the stone. Just add a difference node right over here. So I just duplicate this over here, hit Ctrl D. This I'll disconnect this, I'll connect this over here, and you can add this as a difference over here too. Hit save, and now wherever this cube is, there you will not see the stone or tree be spawned. Now let's talk about how you can use the PCG on top of splines. So let us create a new PCG sample graph. So I'm just going to right click over here, go to PCG, new PCG graph, and PCG splines, right? And I'm just going to drag and drop this right over here in the corner. All right, and here we're going to demonstrate how you can work with splines. So now the PCG splines, you need to actually add a spline component. So click on add and search for spline over here and add spline. Now you will be able to visualize the spline over here. So now on top of the spline, to actually work anything on top of the spline, we need to get the spline data. So get spline data, and the spline is present right in our actor, right? So the actor filter is self. We do not have to find it anywhere else. If you would have to find it anywhere else, you would have done all world actors and then you would search this spline data with the help of the tag, like how we did for that cube before. I'll just search for self, and from the get spline data, we're going to use a sampler. So we're going to use spline sampler. So now this spline sampler we have, let me hit save, and from here you'll find the dimension, it is on top of the spline. So let us actually create or extend the spline. I'm going to use Alt and I'm going to create another segment for this, maybe somewhat like this. All right, and for example I hit D to debug this. We'll find these are the points which will actually create a line. So instead of line, what you can do is add a static mesh on top of this. So going to spawn a static mesh. So which static mesh? So again, from here in the mesh selector, add a mesh entry and go over here. Let us add a simple mesh maybe this flower over here. I will drag and drop this in the static mesh, and you will now find these static meshes are on top of the spline. So this is one way of using the spline in PCG. So now what you can do is click on the spline sampler, and over here it is by default in the subdivision mode. So what this subdivision mode does is subdivision per segment is actually 1. If I set this to 5 or like 2, so in the entire subdivision is going to add 2 static meshes. So instead of this, you can do mode by distance. So now in the entire distance, it is actually setting 1, 2, 3, 4, 5, 6 static meshes. Now you can change that by actually increasing this distance increment. So if I decrease this to maybe like 50, then it will be more static meshes over here, and those are just equally distant with each other, as you can see. So yeah, this is how you can use the spline. Now you can just create more. I just use Alt to create another node over here, and yeah, you can just use it as a spline and it will be spawned procedurally. If I click on the spline sampler again and go to the dimensions, currently it is set on top of spline. I can do it on the interior. If I click on interior, now this has one condition, is your spline should be a closed loop. So let me just delete some of the nodes over here, and I'll right click on the spline and hit closed loop, and now I just resize the spline somewhat like this shape, and let me close the debugging, and now you will find the static meshes are spawned right in between of the spline. So I can just increase this, and accordingly more static meshes will be spawned, right? So if I click on spline, so they will be right following the spline path. If I set this to on interior, it will be from inside of the spline, and right from here you can actually control the inner border and the spacing. I can decrease the spacing to actually increase the amount of static meshes in here. So now with the help of just few of these nodes, we can create an entire forest. So I'm just going to do a quick time lapse of me creating an entire forest on this landscape. So yeah, enjoy the video. Let me know what other tutorial would you like me to create. This was just the start of the PCG. I'm thinking to create more tutorials on top of that. This was just the basic introduction to PCG. So yeah, thank you so much for watching this tutorial. Stay tuned for more.